The National Electrical Code, or NEC, requires ground fault circuit interrupter (GFCI) protection for shower lights in parked trailers due to the increased potential for electrical accidents in damp or wet environments. This requirement stems from the heightened risk of electrocution when electrical equipment is used near water sources. In other areas, such as homes and commercial buildings, the NEC typically does not mandate GFCI protection for shower lights because the risk of electrical accidents is generally considered lower. These locations usually have a decreased probability of water exposure and may not present the same level of safety concerns as parked trailers. The NEC does not specify a maximum ceiling height that triggers GFCI protection requirement. However, some manufacturers of shower light fixtures may recommend GFCI protection for installations in low ceiling areas, irrespective of the location. The reason for this is that the risk of electrical accidents is amplified when electrical equipment is installed in close proximity to water, irrespective of the ceiling height. There exists some inconsistency in the NEC requirements for GFCI protection across different areas. To illustrate, hot tubs and spas necessitate GFCI protection due to the elevated risk of electrical accidents in wet environments, irrespective of their location. However, shower lights in other areas, such as homes and commercial buildings, are not consistently required to have GFCI protection, even though they can present a safety hazard when used in proximity to water. To address the inconsistency in the NEC requirements, a code proposal could be submitted to mandate GFCI protection for shower lights in all areas, irrespective of location or ceiling height. Such a proposal would require evidence of the increased risk of electrical accidents in these areas and demonstrate that GFCI protection would provide a significant safety benefit. The NEC requirements for GFCI protection are based on assessing the risk of electrical accidents in various environments. While there may be inconsistencies in the code's application, the overarching goal is to safeguard individuals using electrical equipment near water. Submitting a code proposal is a legitimate method for suggesting changes to the NEC requirements, but it is crucial to provide evidence to substantiate the proposed changes. The basis of the NEC requirement of GFCI protection in certain areas comes down to risk management and the potential for electric shock. In environments where water is prevalent, the likelihood of electrical current finding a path to ground through a person's body increases significantly. This is because water is a good conductor of electricity, and even a small amount of moisture can create a dangerous situation. Park trailers, for instance, are often located in environments where exposure to the elements is more direct. This can lead to higher humidity levels and increased chances of water intrusion, making GFCI protection for shower lights a critical safety measure. In contrast, residential and commercial buildings are typically designed to provide a more controlled environment, reducing the risk of water exposure near electrical fixtures. However, it is important to recognize that even in these settings, the potential for electrical accidents exists, particularly in bathrooms where showers and bathtubs are common. The absence of a universal requirement for GFCI protection in all shower areas raises the question of whether the current code adequately addresses the risks associated with electrical fixtures near water. While the NEC aims to balance safety with practicality and cost considerations, the inconsistent application of GFCI requirements can lead to confusion and potentially compromise safety. Considering specific scenarios can help illustrate the importance of GFCI protection. Imagine a situation in a residential bathroom where a shower light fixture malfunctions, causing a short circuit. If the fixture is not GFCI protected, the fault current could flow through the person showering, resulting in severe electric shock or even electrocution. The presence of a GFCI device would quickly detect the imbalance in current and trip the circuit, cutting off the power and preventing injury. The argument for extending GFCI protection to all shower lights, regardless of location, is based on the principle of minimizing risk and providing a consistent level of safety for all individuals. While the initial cost of installing GFCI protection may be a factor for some, the potential consequences of an electrical accident far outweigh the financial considerations. Furthermore, the technology for GFCI devices has become more affordable and readily available over time, making it a practical and cost-effective safety measure. When evaluating the NEC requirements, it is also important to consider the role of manufacturers and their recommendations. Some manufacturers of shower light fixtures explicitly recommend GFCI protection for their products, even if it is not mandated by the code in certain situations. These recommendations are often based on the manufacturer's own risk assessments and testing, and they should be taken seriously by installers and homeowners. Adhering to manufacturers' instructions is crucial for ensuring the safe and proper operation of electrical equipment. In addition to code requirements and manufacturers' recommendations, it is also important to consider local regulations and ordinances. Some jurisdictions may have stricter requirements than the NEC, particularly when it comes to electrical safety. It is essential to check with local authorities to ensure compliance with all applicable codes and regulations. The process of submitting a code proposal to the NEC involves several steps. Firstly, a thorough understanding of the existing code and its rationale is necessary. Secondly, gathering evidence to support the proposed change is crucial. This evidence can include accident data, research findings, and expert opinions. Thirdly, the proposal must be clearly and concisely written, outlining the specific changes being proposed and the reasons for those changes. Finally, the proposal must be submitted to the NEC for review and consideration. The NEC decision-making process involves a thorough evaluation of all proposed changes. This includes input from various stakeholders, such as electrical engineers, contractors, manufacturers, and safety experts. The NEC aims to balance safety concerns with practical considerations and cost-effectiveness. The ultimate goal is to develop a code that provides a reasonable level of safety for all individuals while minimizing unnecessary burdens on the electrical industry. In conclusion, the NEC requirements for GFCI protection of shower lights are based on the assessment of risk in different environments. While the code aims to provide a consistent level of safety, inconsistencies in its application can lead to confusion and potentially compromise safety. Submitting a code proposal is a valid method for suggesting changes to the NEC, but it is essential to provide evidence to support the proposed changes and to consider all relevant factors, including manufacturers' recommendations and local regulations. By prioritizing safety and adhering to best practices, it is possible to minimize the risk of electrical accidents and ensure the well-being of individuals using electrical equipment near water. The NEC, formerly known as NFPA 70, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect advancements in technology and address emerging safety concerns. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. The purpose of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safe and reliable operation of electrical systems. GFCI devices work by monitoring the current flowing in a circuit. If there is an imbalance between the outgoing and return current, it indicates that some of the current is leaking to ground. This leakage current can be caused by a variety of factors, such as damaged insulation, faulty equipment, or contact with water. When a GFCI detects a leakage current above a certain threshold, typically 5 amps, it quickly trips the circuit, cutting off the power and preventing electric shock. GFCI devices are designed to react very quickly, typically within 25 seconds, which is fast enough to prevent serious injury. There are 2 main types of GFCI devices: receptacles and circuit breakers. GFCI receptacles are designed to replace standard electrical outlets and provide GFCI protection at the point of use. They are commonly used in bathrooms, kitchens, and other areas where water is present. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. They are often used for circuits that serve multiple outlets or fixtures. The selection of the appropriate type of GFCI device depends on the specific application and the level of protection required. When installing GFCI protection, it is important to follow the manufacturer's instructions and to test the device regularly to ensure that it is functioning properly. GFCI receptacles typically have a test and reset button that can be used to verify their operation. GFCI circuit breakers can be tested using a similar procedure. Regular testing is essential for ensuring that the GFCI device will trip in the event of a ground fault. In addition to GFCI protection, there are other safety measures that can be taken to reduce the risk of electrical accidents in wet environments. These include using properly grounded electrical equipment, avoiding the use of extension cords near water, and ensuring that all electrical connections are properly insulated. It is also important to educate individuals about the hazards of electricity and the importance of following safety precautions. The NEC also addresses the installation of lighting fixtures in bathrooms and other wet locations. It specifies minimum clearances between lighting fixtures and water sources, such as showers and bathtubs. It also requires that lighting fixtures used in wet locations be listed for that purpose, meaning that they have been tested and certified by a recognized testing laboratory. The listing mark indicates that the fixture meets certain safety standards and is suitable for use in a wet environment. When selecting lighting fixtures for bathrooms and other wet locations, it is important to choose fixtures that are specifically designed for that purpose. These fixtures are typically constructed of materials that are resistant to corrosion and water damage. They also have features that help to prevent water from entering the fixture and causing a short circuit. In addition to GFCI protection and proper fixture selection, it is also important to ensure that the wiring in bathrooms and other wet locations is properly installed and maintained. This includes using the correct type of wire, making sure that all connections are tight and secure, and protecting the wiring from physical damage. Regular inspections of the electrical system can help to identify potential problems before they become safety hazards. In conclusion, electrical safety in wet environments is a multifaceted issue that requires a combination of code compliance, proper installation practices, and user awareness. GFCI protection is a critical component of electrical safety, but it is not the only factor to consider. By following the NEC requirements, adhering to manufacturers' recommendations, and educating individuals about the hazards of electricity, it is possible to minimize the risk of electrical accidents and create a safer environment for everyone. The ongoing evolution of the NEC reflects a commitment to continuous improvement in electrical safety. As new technologies emerge and our understanding of electrical hazards grows, the code will continue to adapt to ensure the safety of people and property.